Good morning, children. Now, in this video, I'll discuss about chapter number 2 of ICSE chemistry, chemical bonding. Okay, so we'll start with again I'm referring Virab Dalal book so that you can match with the page number. Go to page number 23. In page number 23, from here on, what you need to focus on this page number 23, you should know what are the condition for the formation of an ionic bond and what are the condition for the formation of a covalent bond. During the formation of a covalent bond, what you need to see, that ionization potential of your metal ion should be low. Okay, second thing, what is the condition for affinity of your non-metal should be high, and the difference in the electronegativity, we know that ionic bond always form between a metal and a non-metal, so the difference in the electronegativity should be high. Okay, a bond which is formed between two metals will be covalent in nature. Okay, and during the formation of a covalent bond, the difference in the electronegativity should be very, very less, or maybe there is no difference in their electronegativity. Okay, so this is something which you need to pay attention from page number 23. Now come to page number 24. In page number 24, you have the two types of bonds, that is why do elements combine? They combine to fulfill their valence shell electrons, right, to become stable. So that can be done by two modes. We know that can be done by transfer of electron from a metal to a non-metal, and can also be done by the sharing of electron between the two non-metals. So when there is a transfer of electron, it results in the formation of the ions. The metal which is losing electron will acquire a positive charge and convert into a cation, and the atom which is gaining electron will be a non-metal. It will acquire a negative charge and it will convert into an ion. Now these two ions are held together by a very strong force, and you need to mention that force in your explanation. That is called electrostatic force of attraction between the two ions. Okay, that is called ionic bonding. And what is electrovalency here? The number of electron which an atom is losing, which metal is losing, that defines its electrovalency. And whenever you are giving the answer for electrovalency, please remember it has to be with the sign, right? Suppose you are giving the electrovalency of sodium, that should be 1 plus. And when you are talking about the electrovalency of a non-metal, the number of electrons which are gained by the non-metal, that is 1 minus, is the electrovalency of your chlorine atom. Okay, so from this page they can ask you about the electrovalency or electrovalent compound. Now we have only 3 examples in our scope, right? As per our ICSE grade 10 syllabus, you have only the structure of NaCl, MgCl2 and CaO. Any one structure can be asked to you in exam in terms of dot structure. Please remember, when you are writing the dot structure, okay, please make sure that you will show the entire formation of NaCl or MgCl2 in the form of an equation. Okay, please remember that you need to show the correct Louis dot structure. Like for sodium, how to write the dot structure? Sodium is having 1 electron in its valence shell, so you will write the symbol of Na as a symbol of sodium with 1 dot, and chlorine with 7 electron, because chlorine is having 7 electrons, so you will write the symbol of chlorine with 7 electron around it, and then you will show the transfer of electron from sodium to chlorine. Remember, when there is transfer of 1 electron, then you will show 1 arrow. If there is a transfer of 2 electron, in case of CaO, calcium is basically losing 2 electron, so you will draw 2 curved arrow from donor to acceptor. If there is a transfer of 3 electron, you do not have any example of 3 electrons, so it's okay, you can do about sodium and calcium, 1 arrow, 2 arrow. Okay, and after the transfer, your chlorine will have total how many electrons? So you will write it in the form of a reaction. So sodium is losing. First, in first step, you will show the transfer. In the second step, you have to show that after losing, sodium will convert into Na+. So that charge is mandatory. In the second structure of Cl minus, you will show that Cl is accepting 1 electron from sodium. So it will have total now 8 electron in its valence shell with 1 minus charge. You need to show the charge. Please make sure that you will represent the charge on these ions. Without charge, your structure will be considered as wrong structure. Okay, this question will come for 2 marks. 1 mark will be awarded for showing the correct representation and transfer, and 1 mark will be awarded for showing the correct charge and the total electrons gained by the negatively charged ion. Okay, so please remember this point. So you can prepare from the structure of CaO, calcium oxide, magnesium chloride, and sodium chloride. Usually they ask calcium oxide and magnesium chloride in your board exam. Now come to your covalent bonding. In covalent bonding, you know, so covalent bonds are formed by mutual sharing of electron. I am in page number 28 of Virab Dalal. Very, very important, the last paragraph, difference between the polar and the non-polar covalent compound. Remember here, very, very important thing is that they can give you the term, the definition, and they can ask you identify the term, right? What is the polar covalent compound? You will say those covalent bonds or covalent compound where the polar covalent bonds are those covalent bonds, right, where you will say the electron, the shared pair of electron is unequally distributed. So here the keyword is unequal distribution. Such bonds are formed by unequal distribution of electron. And another point is there is a charge separation. You can see these 2 points and highlight it. It's already highlighted in your Viraf book. You need to include these 2 terms in your explanation. Charge separation, okay, and second thing, unequal distribution of electrons between the 2 combining atom are the condition for a polar covalent bond. Example is HCl, ammonia, right, and any halogen acid you can write, HCl, HBr, HI, HCl, your HF. Okay, then similarly water molecule is also an example of a polar covalent bond. Okay, next if we talk about polar non-polar covalent compound, in non-polar covalent compound you will say the electron, the shared pair is equally distributed between the 2 atoms. Mostly all the examples are homoatomic molecules, means where the covalent bond is formed between 2 similar atoms. Okay, second thing, electron density is equally distributed, no charge separation. Here let me tell you one more thing, that very important point, that in case of covalent compound usually they highlight this very important, methane and CCl4. CCl4 is a non-polar covalent compound. Please highlight it, make a note of this, because they ask why they won't ask you, because this is something related to a like the concept which is no reasoning is not in your scope, but yes, the example can be given to you. Remember CCl4, even though it is having 4 chlorine atom, 4 polar bonds, but it is an example of a non-polar covalent compound. So this point you should remember. So page number 28, the last paragraph is very, very important. You will definitely get one question from that paragraph. Okay, next is you have a few examples of formation of covalent molecules by electron dot structure. So hydrogen, chlorine, they are very homoatomic, easy one, oxygen, nitrogen. And right here usually they ask the formation of like nitrogen, they can ask you. Now nitrogen is formed, nitrogen is N2 molecule, right, and you know here the bond will form between 2 similar atoms, so you can represent it by dot structure, like you can represent, don't use that orbital structure. Okay, you need to represent the dot structure. So while writing the dot structure, again same format, show the individual atom, that how many electrons are around nitrogen, then do the sharing. Okay, and last you show that what bond will form, single bond, double bond, or triple bond. CCl4 and CH4 are the 2 structure which can also be asked to you. Very important, they ask the structure of CCl4 many times, they asked in board exam, so just pay attention on that. Don't forget to show the electrons around the chlorine atom in CCl4. Okay, similarly you have ammonia and water also. Now let's move on to coordinate bond, very important. In coordinate bond, see almost every alternate year in board exam they are asking either the formation of ammonium ion or the formation of hydronium ion. Okay, the question can be twisted in such a way also, because they can't suppose they don't ask you direct question, they can ask you the twisted way also, like show the formation of the ion when you dissolve ammonia in water. So you know when ammonia dissolved in water, what it will form? It will form ammonium hydroxide. right? Okay, now the question is, show the formation of the ions which are formed when ammonia dissolved in water. So when you dissolve ammonia in water, you will get ammonium hydroxide. So what are the two ions we are getting? Ammonium ion and your hydroxyl ion. So hydroxyl or hydroxide is same thing. Okay, so OH minus and NH4 positive. So you need to show the formation of these two ions. Again, when I am saying formation, please do not directly draw the structure of ammonium. You need to show the steps. How will you show? First you will show the structure, dot structure of ammonia plus H plus, okay, hydrogen H plus. Now you will say ammonia's lone pair is donated to H plus and then ammonium ion will form. Okay, and in ammonium ion, please make sure that there should be one lone pair, three shared pair of electron, and don't forget to put a positive charge around the outside the square bracket. Please remember, because generally student, what I noticed in board exam, they do not show the positive charge and they lose marks. Please remember that when you are writing the structure of ammonium ion, there should be around nitrogen, three shared pair of electron with three hydrogen, one lone pair and one positive charge outside the square bracket. Okay, so this is about your ammonium. Similarly, when you are writing for hydronium ions formation, show the dot structure of water plus H plus gives you hydronium ion. In hydronium ion, again you will show the oxygen is attached with the three hydrogen atom, two are attached with the shared pair, one is attached with the lone pair, and one extra lone pair should also be there in the water molecule. Outside the square bracket you should put a positive charge. And one more thing you remember, wherever you are showing the lone pair of electron, please put it in a oval. Show the pair together in the oval, put a oval around the lone pair of electron. Okay, so these are the small things which you need to focus. Now from page number 33, there, that is your coordinate bonding. Important thing is they can ask you the definition of coordinate bonding. Coordinate bonding definition can be asked to you. Please remember the definition. What is the definition here? The bond which is formed in which electrons are coming from the same atom, okay, or the bond which is formed where the contributing electrons are coming, or both the shared pair of electrons are coming from the same atom. What do you call this bond term? That is coordinate bond, or you can also say dative bond, coordinate bond, or coionic bond. Three bond, the meaning of all the three is same. So you should write either coordinate bond or dative bond. Okay, or they can ask you the definition, or definition will be there, they can ask you the term. Second thing, they can ask you the definition of lone pair of electron. What will be the definition? You will say the unused pair of electron present in the valence shell of an atom in a covalent compound, that is known as its, or in a molecule is its lone pair. So lone pairs definition can be asked to you. And last thing is that very important thing, which, see, one thing is drawing, as I told you, hydronium or ammonium, any one drawing can be asked to you in exam. Okay, and coordinate bond, the example NH4OH, or give an example which show all the three types of bonds in it. So you can write any compound of ammonium. You can say ammonium chloride, ammonium hydroxide, ammonium sulfate, right? And as per with our book, or the simplest example which is given in your book, that is ammonium chloride. So remember, ammonium chloride is an example. They can give you this question in the terms of MCQ also. Four options will be there. The question will be, which one of the following compound contain all the three types of bond. Three types of bond means coordinate, electrovalent, and coordinate bond, ionic bonding, and covalent bonding. So example is ammonium chloride. Okay, how ammonium chloride? Because in ammonium you have coordinate and covalent bonding. And when ammonium ion and chloride ion held together by electrostatic force of attraction, that is your ionic bonding. Okay, so that is an example you remember. Now come to page number 34, which is also equally very important page. They ask reasoning question from page number 34. Remember the first question, there are 9 points which are given. I'll just quickly tell you what type of questions can be asked from page number 34. The first question can be asked to you that what is the reason that why ionic compound exists in crystalline solid, whereas covalent compound exists in soft solid, liquid, or gaseous state. So when you are writing this answer, please make sure that you will write that in covalent bond, in ionic bonding, the force, what type of force is there? You will say in ionic bonding the ions are held together by strong electrostatic force of attraction. Okay, sometimes students write that between the molecule the force of attraction is electric. It's not between molecule, it is between ion. So for this particular question, include electrostatic force of attraction in your explanation. And when you are talking about the state, physical state of your covalent compound, include that, because the molecules are held together by weak van der Waals forces. So here electrostatic force of attraction and here weak van der Waals forces are the two keywords which you should include in your answers. Okay, next is volatility. Okay, that is okay. Then melting point, boiling point, very important point. From this they can ask you the reasoning question, that why ionic compounds have high melting and boiling point, whereas covalent compounds have low mpbp. What is the reason for that? Again the same answer, because in ionic compounds the ions are held together by strong electrostatic force of attraction, whereas in that is why we need a large amount of energy to overcome this force, and hence they have high mpbp. Okay, whereas in covalent compound they have molecules are held together by weak van der Waals forces, so easy to separate, so low mpbp. Keyword is electrostatic force of attraction and weak van der Waals forces. These two terms you should include in your reasoning. Third thing is good conductor of electricity. Your ionic compounds are good conductor of electricity due to the presence of free ions. Okay, and they are bad conductor, covalent compound. Conductivity. Okay, now this point is also important. Fifth point, that covalent compounds are, ionic compounds are good conductor of electricity. Why only in solid state? So when we are asking you why in solid state, you will say because they are good conductor only in molten state and fused state and in aqueous solution, not in solid state. So if they ask you why they cannot conduct electricity in solid state, so you will say because in solid state the ions are held together tightly by strong electrostatic force of attraction. So no free ions. No free ions means no conductivity. Okay, but when you dissolve them in water or when they are in molten or fused state, the ions are free, and because of free ions they can conduct electricity. That is the reason. So this question can be asked to you. Now come to your electrolysis. Yeah, so covalent compounds are very bad conductor of electricity because they don't have ion, whereas ionic compounds in aqueous solution state or in molten state can conduct electricity. They show the process of electrolysis. Next is solubility. All the ionic compounds can be dissolved in polar solvents like water, whereas insoluble in non-polar solvent. And but when I'm asking about the your covalent compounds, they are insoluble. Okay, now here very important point, just pay attention that in covalent compound you need to remember that here you need to bifurcate that we have two types of covalent compound, polar, non-polar. If I am talking about polar covalent non-polar covalent compound, they are not soluble in a polar solvent like water. Okay, but if it is a polar covalent compound like your HCl and ammonia, they are soluble in water. Okay, they are soluble in water. Why they are soluble in water? Because you have a polar covalent compound, and such compounds undergo ionization when dissolved in water, they form ions. Now regarding the reactions are okay, they have very ionic reactions because you have to exchange the ions, so ionic reactions are very fast, whereas your covalent reactions are always slow because that involves the breaking and the formation of bonds. But now the last one, so let me just tell you, in page number 34 you need to mainly pay attention on point number 3, point number 5, point number 7 and point number 9. These are the 4 points where you have to specifically pay attention. Now quickly look at the difference between dissociation and ionization. Very important. What is the difference between dissociation and ionization can be asked to you. Okay, so and maybe the definition will be there, you have to identify whether I'm talking about dissociation and ionization. So what is dissociation? The separation of ions in an ionic compound when dissolved in water. Where you already have ion, you are just separating, like NaCl. All ionic compounds will undergo your dissociation. But if I am saying ionization, ionization is a process of formation of ions from a molecule or from a polar covalent compound when dissolved in water. Okay, so these are the two differences, can be asked to you in terms of difference or can be asked to you in terms of the name or the term. Okay, so these are the topics which we covered from the chapter number 2. Thank you for watching my video. I'll discuss about chapter number 3 in my next video. Thank you everyone.